Okay, we're going to talk about saltatory conduction. Saltatory conduction has to do with the way a signal travels down a neuron that is myelinated. Because remember, when we talked about the basic structure of a neuron, we said that neurons that had a myelin sheath transmit that signal much faster than a neuron that does not have a myelin sheath. So how is that? Well, let's take a look. So remember, the myelin sheath is made up of a collection of Schwann cells that wrap their way around the axon. And the spaces between the Schwann cells are called nodes of Ranvier. Oops. Okay, so here's the difference between an unmyelinated axon and a myelinated axon. So here we have, of course, the high sodium on the outside and the potassium on the inside and the positive and the negative. We have the same thing in this one, but notice that the Schwann cells are insulating the axon. So I only have ions moving in and out of the cell at the nodes, at the gaps between the Schwann cells. Okay, so here is why it's so much faster here. In an unmyelinated neuron, when I have an action potential, okay, it's going to cause sodium channels to open and sodium flows in, and then the sodium is going to cause the next voltage gated channel to open, causing more sodium to go in, and that will open up the next gate, causing more sodium to go in. And in this way, it works its way down the axon. Okay, notice most of the movement is in and out of the cell, not really going along the cell, which is kind of where we want the message to go. Now it's different in a myelinated neuron because of these Schwann cells, the neurons can only move in and out of the cells at the gaps, at the nodes of Ranvier. So what happens when there's an action potential here, sodium ions flow in, and they're going to start to move down the axon. Okay, now the movement is not really up and down so much. Once they move in, they're going to start to spread out. And they're going to start to spread out and move quickly down this direction. And when they get close enough to the next node, it's going to cause the next sodium channel to open, more sodium floods in, and that will move down to the next gap. So the point is that action potential is able to jump from gap to gap. Whereas here, it's jumping from from channel to channel. It's much slower. If you picture two people running a race, this person is taking small steps, so that signal is only going like channel to channel, whereas here, that signal is jumping from gap to gap. It's like this person's taking long strides, this person's taking short strides. Well, who's going to win? Obviously, the long striding competitor. So like we said, when there's an action potential at one node, those sodium ions are going to rush down and they'll open up the sodium channels to the next node. So in that way, that signal is able to jump from gap to gap, and that's called saltatory conduction.